Okay, I'm going to try to plow through some more of test 4. It's late on Friday night, actually very early on Saturday morning at the moment. But so I might be a little more foggy than usual, but let's see what we can do. All right, computational problems. A wire carries a current I1. A second wire carrying current I2 is at an angle of 45 degrees from the first wire. So we have something like this. Wire I1 and wire I2. All right. What is the magnetic field at a point P, a distance L from the point where the wires intersect, located on a line bisecting the angle between them? All right, so what we have is this. And we've got theta, theta. Those are equal angles. We know that what this full theta is, but I'm going to leave it at that for the moment. We have a point P, and this distance here is L. Okay, so once again, strategy. What are we trying to do here? We're trying to determine the magnetic field created by these two wires. How are we going to determine the magnetic field created by two wires? We determine the magnetic field created by one and add it to the magnetic field created by the other. So we just add the two together. So let's figure out what the magnetic field due to I1 is here. So when we do that, let's see, this is probably long enough. I do that a little bit. So what we're looking for is this distance right here. This is, if we took this away and we just looked at point P, this would be how far away point P is from wire 1. Well, what is that? Here's the angle theta, here's L, so we have this triangle right here, L, theta, and D. So what is it? Op over hype, D over L equals sine theta, so D equals L sine theta. Okay, so I'm going to erase all this stuff right now. D equals L, D over L sine theta. Oh, D equals L sine theta, excuse me. So what is the magnetic field due to a wire? Well, you guys know that from Ampere's law, just mu 0 I, which happens to be I1 right now, over 2 pi L sine theta. Now, what is the situation for I2? Well, is this triangle any different from that triangle? No, it's exactly the same. So what do we have? We have mu 0 I2 over 2 pi L sine theta. And what's our total? It is just mu 0 over 2 pi L sine theta times I1 plus I2. And done. So that's half the problem. This is B. The slight difference right now is we don't know whether I1 and I2 are positive or negative, so we don't know how they're going to, we don't know whether they're going to add or subtract, but it doesn't matter because that's not what we're asked. We're asked just to find out what this is. Okay. All right. And then are we done? Yes. So we're done with that. So now assume I1 equals I2. A charge of 0.1 coulomb is sent into the plane of the wires at a velocity of 50 meters per second towards point P. If L equals 10 centimeters, what I is necessary to exert a force of 1.3 times 10 to the minus 3 newtons on the charge as it reaches P? Sketch the direction of I1 and I2. Okay, so let's see, what's the right way to, there's a bunch of different ways we could do this. I'm just going to tell you one way I'm going to start at the end there, where it says sketch the direction of I1 and I2. Well, if I1, let's just say that I1 is in this direction right here. So if I1's in this direction, magnetic field's like that. And once again, this might look like I'm doing it backwards to you guys. Let's see. What would that look like to you? It's going away, so I think it will look like that. I'm just drawing a little offset from here. So that would be I1, looking like this. What about I2? Well, so that was for I1 going in this direction. Well, if I2 was going in the same direction, now we're going to have um, we're going to have a magnetic field. I'm getting screwed up because the going through the glass is backwards. The magnetic field for that is now pointed in the opposite direction. And if I1 equals I2, what's going to happen to this? It's going to go to 0. So we need to have these currents going in opposite directions. It does not matter. I did not give you a... right. I didn't give you a direction of the force. So it doesn't matter which one of these they are, but they have to go in opposite direction. If I1 is going this way, I2 is going this way. If I2 is going this way, I1 is going this way. Okay, so that what I've done right now for I1 and I2, that's fine, a fine sketch for the directions, so I'm just going to leave that there as the final part of the answer. Okay, and I'm going to rewrite this somewhere else. I'm going to try to squeeze it in right here. So what do we have? Mu 0 over 2 pi L sine theta times 2I, because you will recall that this part of the problem, I1 equals I2, and I'm just going to call that I. So that is our B, equals B. And what is B? It is in either, yeah, I'll do this now. I'll go ahead and say that, let's see, say that this is the X direction, this is the Y direction, and then Z would be this way. Once again, I think that's actually going to look backwards from your perspective. So I'm going to draw it like that and hope that it's right. So that would be X, Y, Z. Okay. So B then is either in the plus K or minus K hat direction. So I'm just going to put it like that, and it just doesn't matter which direction it is. Why does it matter which direction it is? Because we are told that the velocity is in the plane of the wires, and therefore the angle between the velocity, let's go ahead and just put the velocity like this. Let's say this is the velocity. The angle between this velocity and the B is going to be 90 degrees. So does it matter if the V was coming in like this, or like this, or like this, or like this? No, it doesn't matter. The angle is 90 degrees. So what that means is our force is going to be QV cross B, which is going to be QVB sine theta, but sine theta is equal to 1, so our force is QVB. Well, what is B? It's just this right here. So our force is QV, and I'm now going to substitute in for B, and I'm going to do that cancellation that I could have done earlier. Mu 0 I over pi L sine theta. All right. What do we ask for? What I is necessary to exert a force of 1.3 times 10 to the minus 3 newtons on the charge as it reaches P. So this is equal to F. This right here is equal to F. And we're just asked for a given number, what current do we need to get? So we're going to rearrange this to solve for I. And what do we have? We have F pi L sine theta over Q V mu 0. It looks like it doesn't look like I have everything there. Pi times pi L sine theta divided by QV mu 0. Okay, and this equals I. And so now all we need to do is put our numbers in. We're done. So I'm just going to go ahead and erase everything and put our givens in. So what are we told? We're told F equals 1.3 times 10 to the minus 3 newtons Yeah, okay, I'm going to leave it at that. L equals 10 centimeters, which is 0.1 meter. Remember, everything needs to be in meters. All our distances need to be in meters. 50 meters per second is our velocity. V equals 50 meters per second. Sine theta. Theta is equal to 22.5 degrees. Sine theta for that is like 0.39, I think. I'm gonna hope I'm remembering that correctly. Sine theta equals 0.39. Let's see. Q is the 0.1 coulomb. So Q equals 0.1 coulomb. F L sine theta V Q. F L sine theta V Q. Okay, so we know everything else, and we know that mu 0 equals 4 pi times 10 to the minus 7th Tesla. Oh gosh, I've got an equation sheet. I can use that. I think it's like newtons per ampere squared, but it also works with Tesla meters per ampere. Okay. Done. Okay. So we're just going to put these in. And so what do we have? Well, our mu 0 is 4 pi times 10 to the minus 7. But we have pi and a pi, so that just gives us a 4. So that's good. All right. So now, now I'm going to go ahead and write this up here. So what do we have? We have 1.3 times 10 to the minus 3. We have 0.1. We have 0.39. I probably should check that, but I'm going to stick with memory for a moment. And then we have 0.1, 50, and then 4 times 10 to the minus 7. Okay, so what do we have here? The 0.1 cancels the 0.1. The 4 cancels the 0.4, which basically this becomes now 0.1. And, what have we done? Let's see, I'm trying to cheat and not pull out a calculator. So let's see what I can do here. So this is 1.3, 1.3 divided by 5 times 10 to the minus 6th. So 0.13, which is 1.3 times 10 to the minus 4 over 50 times 10 to the minus 6th. So 1.3 over 50 is about, 5. That's why I changed this to 10 to the minus 6 instead of 10 to the minus 7. 5 times 10 to the minus 6. So 1.3 over 5 is 2.52. So I'm just going to call that 2.5, except, I'm sorry, it's 0.25. So 0.25 times 10 to the minus 6 becomes 10 to the 6 as we're here, so it becomes 10 to the second. So that means we have 25 amps. Okay, that's that. Numbers and everything.